Hello everyone, JCE Connect. I welcome you all for this particular lecture. In this particular lecture, we'll be discussing about the design procedure of tension members. So in previous lectures, we have seen how to calculate the strength of the member for the given section. There the section was given, and for that section we have been calculated the strength. So in this particular uh, procedure we'll see how the tension members can be designed for the given load. Okay, so the design procedure here is the step number one. The step number one, first we need to find the required gross area for the given load. Find the required gross area to carry a factored load. Here the factored load will be given this load. If suppose the service load or the working load is given, you have to make it a factored, then you have to calculate the required area, and that required area needs to be calculated considering the strength in yielding. So this formula to be used to calculate the required area. So here this uh, the load will be, this is a uh, strength of the member or the factored load will be given in a problem, and for the given load we need to calculate the area required. And step number 2, after calculating the area, select a suitable shape of the section depending upon the type of the structure and the location of the member, such that the gross area is 25 to 40% more than the AZ calculated. Means whatever the area you calculate in step number 1, you increase that area by 25 to 40%, and whatever the area you obtained after increasing 25 to 40%, for that area you refer steel table and assign the section. And this is just a factor of safety. For the on safer side, the 25 to 40% needs to be increased, and whatever the area you get after increasing 25 to 40%, on that area uh, of section needs to be selected from the steel table. Then once you select the section, then determine the number of bolts or welding required. So if it is a bolted connection, calculate the number of bolts required. To calculate number of bolts required, we need to calculate first the bolt value here. Then after calculating a bolt value, then the load will be known. Then load divided by bolt value gives you the number of bolts, or you calculate the length of the weld, then arrange it. So after calculating number of bolts, then we have to arrange in a chain pattern or a diamond pattern. So after arrangement we need to calculate. So first we have calculated area, then for that area we have selected the section from the steel table. Then after selection we have calculated the number of bolts required for the connections. Then after getting a number of bolts, we have arranged that bolts in chain pattern or diamond pattern. So once we have arranged, then we need to check whether the section is safe or not. Safe in three modes of failure. So as we know, the tension member will fail in three modes of failure, that is a gross section yielding, net section rupture, and block shear strength. So these three strength needs to be calculated for the assigned section, that is strength due to gross section yielding, TDG, needs to be calculated. Then the strength due to net section rupture, TDA, needs to be calculated, and the block shear strength needs to be calculated for the assigned section. If the assigned section giving TDZ more than the factored, then it is safe. If it is in a rupture, if it is more than factored the load given, then safe. Then the TDB also, if it comes out to be more than the given, then it is safe. That is in step number 5 what is given, the strength obtained should be more than the factor tension. So whatever the strength you calculate for the assigned section, that is TDZ, TD, and TDB, they should come more than the given load. If it comes to be lesser than the given load, then the section needs to be redesigned. That is step number 5, the strength obtained should be more than the factor tension. If it is too much on higher side, if it means the section whatever you assign, it should not be too much on the higher side. If it is too much on the higher side, or the strength is less than the factored tension, the section may be suitably changed and checked. means whatever the it should not be uneconomical also. So whatever the section you choose, that should be economical, and it should not give a too much on the higher side and also a too much on the lower side. So judicially you need to select and suitably uh, checked. Then step number 6, IS 800 2007 also recommends the check for the slenderness ratio of tension member as per the table 3 of IS 800 2007, page number 20, where the slenderness ratios are being given. So I'll show you in the code book the slenderness ratios, page number 20. If you refer page number 20, so here they mentioned here. So maximum effective slenderness ratio here. So please go through this code book. The maximum effective slenderness ratio, that is KL by R, values of beam, strut or tension member shall not exceed those given in table number 3, where KL is the effective length of the member and R is the appropriate radius of gyration based on the effective section as defined in 3.6.1. Okay, then here some of the slenderness ratios are been given. So please refer code maximum values of slenderness, maximum values of effective slenderness ratios. Here the member a member carrying compressive loads resulting from dead loads and imposed loads, the maximum effective slenderness ratio should be 180. A tension member, here it comes, the tension member, a tension member in which a reversal of direct stress occurs due to loads other than the wind or seismic forces, 180. A member subjected to compression forces resulting only from combination of with wind or earthquake actions, provided the deformation of such member does not adversely affect the stress in any part of the structure, that is 250. So likewise the slenderness ratios are been given here. So you, with respect to this, we need to calculate the slenderness ratio for the assigned section. So many times what happens in a tension member, there could not be any buckling action, but it is only possible whenever the load get reversed, means the tension become compression, compression become tension. In such cases we need to know the slenderness ratio of that particular member. So for that reason we need to calculate the slenderness ratio of tension members. So this particular aspect also needs to be checked while designing the uh, tension members. So this is the procedure, so you need to follow. So the design procedure, you follow this procedure, and in next part of my lectures I'll be taking a one design problem and you'll understand these all steps given here. That is step number 1. In step number 1, I'll repeat. In step number 1 we need to calculate first the area for the given load, and whatever the area you calculate, you increase that area by 25 to 40%. Then for that increased area you select a suitable section from the steel table. Then after selecting a suitable section from the steel table, take the properties of that section, then calculate the number of bolts or the weld, means it depends upon the type of or the what whether you are providing a bolts or the weld, it depends. If you are providing a bolts, calculate number of bolts. If you are providing a weld, calculate length of the weld and arrange it. And bolts to be calculated based on the bolt value, calculate a bolt value, then calculate number of bolts. Once you get the bolts and sections assigned, then just you connect it and arrange the bolts. Then after arranging the bolts, calculate that section, whether that assigned section is safe or not, by calculating the three modes of failure strength, that is strength due to yielding, strength due to rupture, strength due to block shear. These are the three modes of failure. The strength of these three modes needs to be calculated for the assigned section. Then if the strength comes out to be more than the given load, then it is safe. If not coming, just you revise the section and once again do checks. Okay, so the last step needs to be followed is you need to calculate the slenderness ratio of the tension members. So this is the procedure you need to follow. Thank you.